Hello everyone, you're welcome to Teach Mathematics with Deyemi. Today I'm going to teach you about the laws of indices. 1. A raised power of m times a raised power of n is expressed as a raised power of m plus n. That is, when we have expressions with identical bases, this base is a, the base is a. When we find the product of expressions with the same base, it can be expressed as we write the base and then we find the sum of the parts. For instance, we have a 2 raised power 3 times 2 raised power 5. This can be expressed as 2 raised power 3 plus 5. Why? Because they have identical bases and then we are finding the products of these two expressions. 2. The second law here is a raised to power of m divided by a raised power of n can be expressed as a raised power of m minus n. This law makes provision for expressions in the same base and when we are dividing. That is, when we are dividing with expressions in the same base, we can write it as the base raised to power the difference between the powers. For instance, we have a 5 raised power 3 divided by 5 raised power 2. This can be written as 5 raised power 3 minus 2. And so this is 5 raised power 1. And so this law makes provision for division of numbers in the same base. 3. A raised power 0 is equals to 1. What this means is whatever is raised to a power of 0 gives you a 1. Whatever 500 raised power 0, it is 1. 1,000, 1,000,000 raised to power 0, it is 1. So whatever is raised to a power of 0 gives us a value of 1. Whatever is raised to power 0. The next law here is a raised power of minus n. This is an expression with a negative power. And so this can be written as 1 over a raised power of n. That is, whenever we have a single base like this, that is not a fraction, a single base, a raised power minus n, this can be written as 1 over a raised power of n. And so the power becomes positive. For instance, if we have an expression like 5 raised power minus 2, this can be written as 1 over 5 raised power 2. And when this is evaluated, you have 1 over 25. And so this makes a provision for an expression with a negative power. Now the other one that looks like this is when we have an expression like a over b raised power minus n. In the same manner, the base here is a fraction, a over b. The power is minus n. And so we can make this negative power become positive. To do that, we invert the base. That is, you just turn the base upside down. This becomes b over a all raised power plus n. Whenever the base is a fraction and the power is negative, for instance, if you have an expression like 3 over 2 all raised power minus 4. So this can be written as 2 over 3 all raised power plus 4. And so this law makes provision for expressions with fractions at the base having negative power. Now, the other law that also look like this, I'm trying to just expand. The major law here is this point, and so I'm expanding it because you could see this come out in different ways. For instance, a over b all raised power minus n over m. The base is a fraction. The power is also a fraction. But the power here is a negative fraction. Whenever the base is a fraction and the power is negative, to make the power positive, you invert the base. Again, when the base is a fraction like this, a over b, and the power is negative, to make the power become positive, we invert the base. And so this becomes b over a all raised to the power of n over m. Now the point of this is that you don't invert the power. The power is a fraction. You don't invert the power. The only thing that happens to the power is that the sign changes from negative to become positive. And of course, the same way we change from negative powers to become positive powers, we can also change from positive powers to become negative powers, depending on the situation, depending on the problem we are solving. If you need to solve a problem where the power is negative and what you have is positive, then you do the same thing. For instance, if we have m over n, all raised to the power of, let's say, a over b, and you need to make this power negative, then you invert the base. It becomes n over m, all raised to the power minus a over b. And so, the same way you move forward, you can also move backward. So, we make negative power become positive, and we can also make positive power become negative. Alright, the other law I want to talk about, okay, let's just put this here. Point 7 will be a raised to the power of m, all raised to the power of n. This can be written as a raised to the power of m times n. This is expressed as a raised to the power of m times n. Okay, to the next one. Let's talk about this law. A over b, all raised to the power of n. When this is expanded, it becomes a raised to the power of n over b raised to the power of n. And so, the lookalike to this would be point 9, where I have ab, all raised to the power of n, is written as a raised to the power of n times b raised to the power of n. So, when we have the product of two expressions raised to a power, so it could be expanded as each of the term in the bracket raised to whatever the power is. And the last one I'll talk about is a raised to the power of m over n is written as the nth root of a all raised to the power of m. That is, when we have an expression where the power is a fraction, it can be evaluated or written as the nth root. N is the denominator of the power and m is the numerator of the power. So it becomes the nth root of whatever the base is. The base is a. That's why this is the nth root of a all raised to the power of m. And so with this, you have all of the laws of indices. All of those laws will help you to solve all kinds of indicial expressions, exponential equations. If this video is helpful, please click on the subscribe button and the like button in order for you not to miss the next video I'm going to share with you. Thank you for watching. See you in the next class. Bye-bye.